fixed functions. So a couple different customer pain points and use cases. First is needing the ability to compare different group averages to an overall average or number on the data set. The second one here is similar to the first one, but excluding one column or calculation from being affected by any filters that are being applied to the card, allowing for some really cool dynamic comparisons. And the last one here is removing duplicate rows based on a different column that's not in the current chart query and analyzer, actually needing to run a data flow. So being able to do all of that from analyzer. So of course, the solution here is fixed functions. These functions allow analysts to create really powerful subquery calculations for more flexible data grouping, joining, and comparisons. And as you can see, we have these three new available functions listed here in the beast mode editor alongside the other available functions. So we have fixed add, fixed by, which is going to be your standard, and fixed remove. You can also just use fixed by itself for a very, very general calculation. So I'll go ahead and present a quick demo of fixed functions and the use cases here. So a very general use case here, an example of when to use fixed function. In this example, we've used the fixed function as seen above. So we're taking the sum of total sales and using this fixed function here with empty parentheses. So we have a double aggregate. The reason, in fixed functions, you do have to use an aggregate function wrapped with another aggregate. So we have the sum of total sales. And you can see in this example, we have different sales by states and the country sales. So we have, California, Utah, Nevada, and the total state sales for that state. But then using fixed function, we're able to get this total US sales calculation. So we can see 8 billion is the sales for the total US, and we can see that alongside each of the states in the table. So this can be really powerful as you're able to essentially fix or lock in a calculation and place it there in this column. And you can see that calculation regardless of the level of detail being displayed in the chart. So even though we're breaking this out by state, we can still see the total US sales alongside each state sales. Similarly, using this fixed by, we're now able to group that calculation or fix the calculation by a specific group. So in this example, we're fixing it by region. And very similar to the example above, we're using the sum of total sales fixed by region. We see the different states. These ones all belong to the West region. And so because we're fixing this calculation now by region, we're able to see the West region's total sales alongside each of those states. So now all the West states, you can see, have this 3.74 billion. But then when we drop down to Southeast, you can see that the region total sales number here is going to be different. Now, this can be really useful in performing other calculations based on that number. So in this example, you can do a really simple percent of total calculation. So you can see we did the sum of total sales divided by this region total sales fixed calculation. So we have the different states, California, Utah, Nevada, and then we see the percent of region total that state sales makes up. So California, the 1.39 billion makes up 37% of the West region's total sales, and we can see that region total sales. So it allows for some really cool fixed calculations that you can do on the data set, regardless of the level of detail that's being shown in the table. Now, similarly, we can also use this filter argument here. As you can see in this example here, we're using the filter none argument. You can also use filter allow or filter deny. And so using this filter none, we're essentially preventing any filters from being applied to the calculation. So here's an example where we're seeing sales by state in the yellow bar, region, and total US. And you can see that the region and total US sales look the same. Obviously, that is inaccurate. And so using this filter none, what we're allowed to do is actually prevent this calculation from being affected by any filters being applied to the chart. So in this example right now, in this chart, we're seeing these sales are all being filtered to just the West region. And because of that, the US total sales calculation is only pulling from a view of the data set that is filtered to the West region's data. So it's going to be the same as the region sales. Similarly, the same thing happens if we filter to California. All these get narrowed down to only California sales, so they're all going to show up the same. But when we use this fixed filter none calculation, we're able to prevent that calculation from being affected by any filters being applied. So we can leave those calculations true to what they should be. Similarly, we can use filter allow, which will allow specific columns from affecting the calculation if they're filtered. So in this example, we would like to allow product category to filter on this calculation. So for example, this chart is using the same chart we were using up above there with filter none. And so if I filter to apparel, you'll see that only this state sales calculation, because all that is the sum of total sales. We're not using a fixed calculation there. This calculation will be affected by the category filter. But if we use this filter allow and allow product category, you can see that on the right, all 3 bars here get filtered down to show only the apparel product category. So that just allows for some really cool customizability in exactly which columns are allowed to filter your calculations. And in contrast, you can use filter deny, which essentially just is the opposite of filter allow. It will allow all filters from being applied to the calculation except for specified filters. So in this example, we are preventing just the state filter from being applied. So you get the same results as above, but sort of from the opposite direction. And finally, instead of fixed or fixed by, you can also use the fixed add or fixed remove functions. So fixed add will essentially return the aggregate value and then add a dimension that is specified in the calculation. So if we remove these filters here, you can see that in this example, we are displaying different states across the bottom here on the x-axis. And so we see California, Nevada, Utah. And in this chart, we are showing the max total sales of a city in those states. So this is showing the max city sales for each state without actually displaying the city name. So this is really cool. We're adding that city dimension to the calculation. So you can see for California, the max city sales was 5.98 million. And we can use that calculation, but keep the same level of detail that we'd like to in the calculation. Allows for some really great flexibility and customizability in displaying exactly what you'd like to in your chart. We also have fixed remove. Similar to the one above, we are removing a dimension that's specified in the calculation. So in this example, we're displaying the average unit price for each product category in blue. So we see apparel, the average unit price is $47.70. And in the gray, we're using this average unit price fixed remove product category. So what we're doing here is removing that dimension from the calculation so that we can get the overall average unit price. So we can see the side by side, we can see that, okay, apparel, the average unit price is $47 compared to the overall average, which is $88. So again, just allows for some great customizability and flexibility to show exactly the numbers and level of detail that you'd like to in your calculation.